We all have our little green tickets. That's a reminder to me that I'm standing between you and lunch. And I was originally given an hour and a half, which I was going to break into talking and then kind of a group activity in small groups. I will try to talk less and we'll have shorter breakout groups also. Or maybe, okay. So I'm here today to talk about personal monitoring. So far, we've really been focused on ambient monitoring. And in fact, most of this workshop, I think, is going to focus on ambient monitoring. But, you know, the ambient monitors sit in one location. If we sat next to those ambient monitors all the time and did nothing, then that would be a great way to understand our exposure to air pollution, sitting next to that air monitoring, doing nothing. But that's not what we do. We walk about, we have activities, we go strange places. You know, in some cities, there's the bus systems, there's the tut-tuts, there's subways in some places. And we do a lot of activities very close to major point sources. In Africa, what's one of the major point sources that many people, especially women, are exposed to? Anyone? Cooking, right? Cooking is a major point source. Especially when you're cooking over a solid fuel with an inefficient stove, maybe with wet wood or dung. And so there's times when a personal exposure monitor is really important if you really want to understand what people are being exposed to. There's other times when it's just really useful for telling a narrative, like when you want to talk to the press and you want them to understand what are the sources of air pollution going on. Personal monitoring can be very useful for that too. And there've been some very successful major stories using just 2 people with 2 air monitors that have had a lot of impact in India. And then you can also have personal monitoring that is checking whether you're missing any important sources from your ambient samples. And in the big picture, that's kind of the 3 use cases. In a health study where you really want to know what individuals are exposed to, in kind of outreach when you want to educate people about different sources, and then if you just want to check if you're missing anything from your ambient air monitors. So that's a long. Oh, next slide, please. So here's my outline, and I'm going to try to cut a lot, but that was my introduction to personal monitoring, and I have one example that I'm wearing here, and we're gonna pass these around. I have my neighbor at the table. We're gonna pass. We have 2 of each type. So we'll pass them down. You all get to look at them. So I'm gonna give you. Those are the examples you get to look at. This is an area where new monitors are being developed all the time. So these are just a few examples. There's 3 different types that are going to go around. I'm going to give you 3 case studies, maybe not in as much detail on the one that I was going to go long on, to show you kind of the utility of personal monitoring. And then we are going to have these breakout sessions, and then you're going to report back. In the breakout sessions, my idea is if 2 tables got together, so if the people facing front just turned around and talked to the table behind, that would be a breakout group. And then there'd be roughly 10 breakout groups. Okay, next slide, please. So, you know, in epidemiology, we're always interested in understanding what sources are because that's the policy implications. If you know what the source that's causing a health impact, then you can try to create policies to improve it. But a source doesn't tell you everything. You have to know the atmospheric chemistry, the fate and transport, and how that gets to people and their exposure pathways. And it's that fate and transport that actually determines the concentration that an individual might be exposed to. And then we have to measure that exposure somehow. And traditionally, that's always been done with ambient air monitors, but there's more and more personal work being done. Why? Because the personal monitors have shrunk to much smaller sizes, making it more easy to do. Next slide, please. So here's an example of where emissions is very different than exposures. And this is a really old example. This is from the 1980s, when in the United States, there was a lot of smoking going on. And if you looked at the emissions of benzene to the environment, most of it was coming out of the gasoline in motor vehicles. So 82%. The mass of benzene coming out of cigarettes was minuscule, 0.1%. Next slide. But if you looked at the exposure, cigarette exposure for humans in the United States on average was driven by the cigarette smoking, either direct smoking or environmental tobacco smoke. And so very different than the emission sources. So that's just an example. Next slide, please. And when we think about epidemiology, you know, a lot of this began in Europe and the United States. And for decades, what's driven policy is what we call intercity epidemiology. And this is one of the most famous cases. You've probably all read this or heard of this, the Harvard 6-city study, where they followed cohorts of people in 6 different cities. They measured the ambient air pollution at 1 or 2 ambient monitors in the city. I actually don't know, but a small number. But there were large differences between the cities, as in compared to the measurement error of the ambient air monitor, there was measurable differences. And so you went from the lowest city, Philadelphia, having around 11, and the highest one, I think, was St. Louis, but I don't remember, was around 30. And they saw that the relative risk of death was linear in their modeled results. And this has driven policy for decades. Next slide, please. Intracity variability of air pollution has been the focus for the last couple of decades, and it has continued to drive policy because we've seen a lot of spatial and temporal variability, enough where people are demanding more air monitors be put up, especially in low and middle or in environmental justice communities that have been disadvantaged, and guess what? Typically don't have any air monitors. And what we see is that those, you know, just from fixed site ambient, we see that those environmental justice communities typically have higher air pollution, not always, and typically have much higher health risks. This also highlights that all this spatial variability highlights the need for personal monitoring, because people move about. And if there's all that spatial variability, how do you know that someone was standing next to that ambient air monitor all the time? Next slide, please. So what are we trying to learn? You know, on the right-hand side, we have a community. This is the fringe of the community. And here's a GPS track of the person. The red blotch is when they were at home. The green was when they were in the community. boundaries, and the blue is when they're outside of the community boundaries, something that you can write a script with your GPS and figure out. And so that if you had real-time personal monitoring, you could see where the exposures are, which helps you identify sources. So that's one of the reasons why what we're trying to learn from personal monitoring, especially now, is we're having continuous monitors that measure minute by minute. People's behavior and activities affect exposure. So we're trying to figure that out. I already mentioned about, did we miss anything? We'll give an example on endotoxins in a moment. And so for all, in reality, in the public health field, personal monitoring has been seen as the gold standard as long as it's done well. And we've heard this morning all about the importance of calibrating your low-cost sensors to a reference grade monitor at a fixed site. Well, we can't put a reference grade monitor on a person. They weigh too much. They need line power. They're too expensive. But what we can do is still collect for particulate matter, we can collect a filter. And so we calibrate the low-cost PM sensor, its average over its whole deployment time, to a filter weight. And that's the best we can do. It's not perfect, but it's better than not calibrating it. But personal monitoring is a lot of work. I mean, it just is. You're never going to be able to look at as many people with personal monitoring as you look at with ambient monitoring. And so these studies are usually focused on a given point or a very specific health outcome where you, or a specific activity like household air pollution, where it's been shown that other methods just have too much error, too much exposure misclassification. And in household air pollution, it's been shown by a couple of studies that you need to do repeated measurements if you want to estimate the long-term exposure. And so you can't just do this once. You really need to do it a couple of times for each season or each year that you want to be looking at chronic exposure outcomes. If you're looking at acute exposure outcomes, well, then you still need enough data so that you have enough health outcome data too. Next slide, please. And so a lot of the reasoning for personal monitoring is trying to avoid the exposure misclassification from other methods, from questionnaires, from the central site, as well as telling us something about the sources, because biomonitoring is a great way for certain things like lead in blood for understanding exposure. There's not always a biomarker of exposure for a source that you're interested in, and it's often very hard to know from the biomonitoring what the sources are. So that's the other reason. Next slide, please. So if you're doing personal monitoring, you have to think not only what device are you going to have, but how are you going to wear it? And this is my first personal exposure study. Oh, thank you. Back then, the pumps were really heavy. The batteries were even heavier. So we had 3.2 kilograms to go for 48 hours to get integrative samples, no real time, but we were able to get VOCs, aldehydes, and PM. But next slide.